Okay. Can you see my screen?
Yes, I can.
Okay. So in previous lectures, as we are already studying the mapping and one-on-one mapping, many mappings, and also their functions and functions types, and we are working on the functions of their types.
Yes, sir.
Okay. From that problems, this is first one. So basically, this is related to our previous one work. Look at here.
Yeah,
Sketch the functions and state whether it is one or many two functions. So
sure. I'll do.
so this is the function, x plus 3. We have the if we are working on the real line, this is the 0. So when we put x is equal to 0, this gives us x is equal to 0. This is y is equal to 3. So this is the order pair is 0 and 3. And same for if we put x is equal to 1, so y is equal to 4. This is 1 and 4. Same for when we have x is equal to 2, it gives us 2 and 2, 5. Okay, and same for the
Yeah,
negative sense, when we have x is equal to -1, so it gives -1 plus 3. It gives y is equal to -1 plus 3. This is equal to 2. So our order pair is what? -1 and 2. And when we put x is equal to -2, this gives y is equal to -2 plus 3. This is what? So our order pair is what? -2 and 1. Look at it here. These are our ordered pair that we have got. Okay. So
okay.
now we are moving to the sketch the functions. Sketch each functions and state whether it is one or many and one functions. So first of one, our demand is what? We want to construct our functions graph. So for the graph, we want to find their ordered pair, their ordered
Yeah,
pair. Okay. So when we have x is equal to 0 and 3, x is equal to 0, we have the 3. So x is 0 is here and 1, 2, 3. This is our first one.
yeah,
Okay. And when we have x is equal to 1, so our 1 and 4. So this is 1 and this is 4. Mm, So maybe here is our point. When we have x is equal to 2, this is the 5. So this is 2, this is 5, and this is 2. And this is, and when we have x is equal to -1, so x is equal to -1, it gives the positive 2. So this is the -1, 0, 1, and 2. This is
yes, sir.
okay. So when we have -2 and 1, x is equal to -2. This is the -2 and this is the -1. Look at here. So we are making the graphical representation. So this is this is like this type of this type. So from here,
Yes, sir. See, can I do the B? Because I'll try doing it.
okay.
I'll do B. I'm almost done, sir.
Okay.
Yes, sir. So the function x squared minus 1 is many to 1.
Many to one. But here, this is the many to one, but here, this is the one
That's
function.
1 to 1.
Wha- This is the one function. Why, if I'm making the horizontal line in our previous section, we are already discussed horizontal line is what? It is the parallel line to the along the x-axis. So suppose that I'm draw the with highlighters. So look at here. This is our horizontal line test.
Yes, sir.
Horizontal line test, and on the behalf of this test, the line is touch to the graph at 1 point. Look at here, not more than 1 point. That's why we are saying that this function is one function. And on the other side, the second one example, y is equal to x square minus 1. If I'm making the factors, so x minus 1 and x plus 1. How I'm making? Look at here. This is the x square, this is minus 1. You know, minus 1 square, this is equal to 1. So this is x minus 1 and x plus 1. When we put single input, so x is equal to, if I'm supposing, if we put x is equal to 0, so from this one, y is equal to x minus 1 and y is equal to x plus 1. When we put x is equal to 0, so it gives minus 1 and y is equal to plus 1. So here from this one, our input is what? Our input is 1. Our input is single, but our output is double. Our output is double. In graphical representations, single input and it gives double output. Double output, and from that, on the behalf of this one, we can conclude that our graphical representation is like this type of U shape. And when we draw the horizontal line test, look at here. Our horizontal line can be the cross touch the function at the two different points. That's why we are saying that this is the many functions. Okay.
Yeah.
So any confusion from this one problem, from these two problems?
No, sir. No confusion.
Okay. So now we are moving to the our inverse of the functions. As already we discussed in previous sections, the functions, no, and we are writing f of x, and now we want to find the f inverse of a function. In referee language, inverse function is the reciprocal functions. So how we are finding the reciprocal functions? Look at it here. Our function f of x is equal to 3x
Yes.
plus 2. Use a flowchart to find the inverse of the functions. Inverse functions sketch the graph of the f of x, f inverse of x on the same axis. Use the same sketch on the both axes. What do you notice? So basically, first we have to want to find the inverse function. So inverse function for this one, we are going to this one here, flow chart. We are using the flow chart. You know, the simplifications. And this is the division. 2 is divided. This will be going to the this side. So this is equal to 2y is equal to 3 of x plus 2. And you know, this is the plus 2. This is 2y. This will becomes here. This is the minus 2 is equal to 3 of x. So we are dividing on the both sides by 3. In inverse functions, we are using these techniques, and we can separate the x values to the one side of the equation, and rest of the a values are the other side of the equation. Okay, so look at
Okay.
here. X is equal to 2y minus 2. This is 3. So from that, on the behalf of this one, this is the f inverse of the functions. Or we are writing, if we have the replace f inverse of the, this is the f inverse of x is equal to 2y minus 2 and 3. And no, here we are using the replacing technique. Replacing technique is what, replace x to the y and y to the x, x to the y and y to the x. So this function is like this type.
Yeah.
Are you understand how I'm making
Yes.
this type of functions? So this is the inverse of that functions. So this is the inverse of the that functions. So our look at here. Our function is what, original function f of x is equal to 3x plus 2. 3x plus 2 divided by 3x plus 2 divided by 2, and our inverse function is uh, f inverse of x is equal to 2 of x minus 2 over 3. Now we want, what is our second one step is what, sketch the graph of the function also inverse on the same axis, use the same sketch on the both axes. And what do you notice? So before of this one, you know, we have we do the graph. So for the we put different point. So our y is equal to, this gives is equal to y is equal to 0 plus 2 over 2. This is 0. So this is 0 and 0. When we are setting x is equal to 1. So our functions is y is equal to 3 into 1, 3 plus 2 over 2. This is equal to 5 over 2. So this is 1 and 5 over 2. And when we set x is equal to 2, so this gives y is equal to 3 into 2. This is the 6. 3 multiplied by 2, 6 plus 2 divided by 2. So it gives 4. And this is the 2 and 4. Can you got it? How
Yeah.
is it 4? Okay.
Okay.
No, no, then we are moving to the next one, to the negative side. So our x is equal to minus 1. So y is equal to, you have put, this is minus 3 plus 2 divided by 2. This is the my minus 1 by 2. So our order pair is 1 and minus 1 over 2. And same for the x is equal to minus 2. This is 3 into minus 2, and y is equal to 3 into minus 2 plus 2 divided by 2. So minus 6 plus 2, this is equal to minus 4, minus 4 by 2, this is minus 2. So this is the, our order pair is minus 2 and minus 2. And on the behalf of these order pair, I'm making the graphical representations. But before of this one, student can confused for how we are draw the graph of like that type of the order pair. So don't be panic. You can convert it 5 by 2. This is equal to the 2.5. Got it?
Yeah.
I'm just simplify it. I'm dividing it. So this is also minus 1. This is minus 0.5. So So you are drawing the graph of this one. First one is when we put 0, this is the 0. And when we put our x is equal to 1, this is 1 and 2.5. X is equal to 1 and y is equal to, this is 0, this is 1, this is 2, and this is 3, but 2.5, 2.1 and 2.5. So this is 1 and this is the 2.5. When we
Yeah.
put x is equal to 2, this is the 2 and this is 3 and this is the 4.
Yeah.
Okay, then we are moving to the negative side. X is equal to -1, y is equal to -0 and 1. This is the 0.5 and this is the -1. After this, this is the -2 and -2. Look at here. This is 0, 1 and 2. This is 1, 1 and 2. This is 1 and -2 and 2. -2 and 2, and this is 1 and 0 and 5. So how can you make the graph of this one type function? Okay,
Okay.
so from this one side, look at here. This is 1 function or not? See, see, check. This is
Yes.
1 or not with the
This
help
is
of
112.
1. Then we are moving to the so for the same steps you are following. Can I try it or you should also try it?
I'll try to.
Okay.
So I have to find out whether this is 1 to 1 or many to 1.
Yeah, look at here. Basically, what do you notice? So before of the notice, we want to the graph because after the graph we can calculate about the graphical representation of the dat functions. So basically, he want to asking about the graphical representation of the inverse function as well as their original function. Okay.
Yeah. I'm doing so.
Okay. Okay.
Let's say, can I get some water and come back?
Hmm. What are you saying?
Can I get some water and come back real quick?
Okay, okay,
Thank you, sir. Just give me 2 minutes.
okay.
Yes, I'm back. I'm gonna finish doing this.
Okay,
It's 1 2 1, sir.
it's 1 2. Okay,
Yes.
okay. So, what are you saying about this one? So, what is your conclusion about that functions? Also, their inverse of the function.
Yes, sir. Every out input has a unique output. Every output comes from exactly one output, and it passes on the horizontal line. So it is a linear function with zero gradient. So sorry, non-zero gradient. 2/3.
Okay, so the graph of the function and its inverse are the mirror images. Because mirror images, I'm just writing the functions if f of x, so this is 1 over f of x, or this is we are writing f inverse of x. So this and this function are same but with different signs. Maybe this function is positive, but this is negative. Maybe this function is negative and this is positive functions. Okay, this is the true
Yeah.
for every function that has no inverse. Okay, draw the both on the same scales, and that's why the our graph of the y is equal to f of x. Our graph y is equal to f of x and y is equal to f inverse of x are the same. Okay,
Yeah.
so after this, now we are moving to the next one problems. Yeah, this is that one. Okay, look at here. Sketch the graph of the functions f of x is equal to x squared or minus 4 to 4. So explain the using the example why the f of x does not have an inverse with that and its domain. Suggest the suitable domain for f of x so that an inverse can be found. An inverse can be found. You know, this is the quadratic functions, and keep it in your mind. The quadratic functions, it's always graphical representation is like U-shaped or like this type of this shape.
Yes.
Okay.
Parabola.
Yes, parabola. That's a very nice point. So from this one, our function f of x is equal to x square, and its domain is minus 4, and we are restricted from minus 4 is less than x and x is less than 4. So uh, sketch the graph of the functions. So we when we put our x is equal to 0, so y is equal to 0. It gave when we put 1, it gives the 1 and 1. So it's graphical representation is like this type of this one. So this is the 4. So this is 4, this is 1, this is 2, this is 3, and this is 4. This is minus 1, this is minus 2, this is minus 3, and this is minus 4. So if I'm drawing to this one, so this is the our domain of the graphical representations. In general, our graph is like this type, but here we have the this type of the condition. That's why I'm this, fill with the different color and will fill with it. This is our that one. Okay, the domain.
Yeah.
Explain using examples why f of x does not have the inverse. So why it is not inverse? You know, look at here. If y is equal to x square, so y is equal to, when we put under root on both sides, this is the plus minus 1. So this is x is equal to plus minus 1 y under root, and we are again replacing the x to the y and y to the x. So this is y is equal to plus minus x under root, and from this one, if I'm taking the square, if I'm taking the square, this is y square is equal to x. Okay, that's why
Yeah.
that's why this function has no inverse functions. Okay,
Yes, sir.
and suggest a suitable domain for f of x so that the inverse can be the found. So suitable for what do you think about this one? What is the suitable reason for this one, or suitable
Suitable domain. It
hmm,
could be.
mhm.
I'll do it, sir.
Okay, okay, you can work it.
Yeah. 0
Mhm.
is less than or equal to x, and is x is less than or equal to 4.
Yes. So the you are saying about like this type. Okay. So after this,
Yeah.
hmm, after this we are moving to the next one example. find the G inverse of as already we are discussed. So G of x is equal to what? X over 3 plus 4. This is y. This is equal to y is equal to x over 3 plus 4. So y minus 4 is equal to x over 3. So this is 3y minus 12 is equal to x. So we are replacing as x to the y and y to the x. So this is 3 of x minus 12 is e equal to y. So our inverse function is what? F inverse of x is equal to 3 of x minus 12. Sketch the graph,
Yeah.
y, this and this on the same axis, use the same scales. Okay. Can you try it, please? Sketch up that function.
Yes, sir.
Okay, please.
I will do it, but then I can't send it to you unfortunately because my dad went outside and we don't have the phone. When I'm sending my homework, I'll send this to you with it.
Sorry, what are you saying?
I can't send you the picture because my dad went outside. But then when I send you the homework tomorrow, I'll send you this work as well with it.
Okay, okay, no issue.
I'll do A first.
Okay.